Watch a screen of pure random static slowly turn into a real picture. No brush, no strokes, just noise, carefully taken away. That is how every modern AI image generator works. Let's build it up, from one picture to the whole idea. Start with a single real image. Now add a little noise, again and again, until nothing is left but static. That slow slide from picture to noise is literally a diffusion process, like a drop of ink spreading through water. It's entropy in action. Order dissolving into disorder, the way ink or heat always spreads out and never gathers back on its own.
So diffusion is the picture dissolving into noise, not the picture coming out?
Right. And the whole trick is teaching an AI to run that diffusion backwards, to unmix the ink. How does it learn to reverse that? Take an image and add a known amount of noise. That single line of math on screen is exactly that step. Heap a shrinking slice of the real image, and mix in that much pure noise. It's really just one step of a random walk, written so you can jump straight to any noise level. Then ask the AI one question: how much noise did I just add? Repeat billions of times, at every level.
So its whole education is just guessing the noise?
Once it can spot the noise in anything, it can also remove it. Now make a picture. Start from pure static, ask the AI what noise to remove, and subtract just a little. Repeat that 20 to 50 times, and a real image is left behind.
So it never really draws, it just keeps taking noise away?
Exactly. The picture was hiding in the static all along. The model just knew what to subtract. But why creep up on it? Why not output the finished image in one shot? Because nailing millions of pixels, all agreeing with each other, in a single guess is brutally hard.
So breaking it into small steps just makes each one easy enough to get right?
That's the idea. It turns one impossible leap into a gentle climb, and it trains stably and stays endlessly varied. One more piece: how does it know to make a cat, and not a car?
Right, where do the words even come in?
We feed them in as a hint, learned alongside millions of image and caption pairs. The prompt tilts every denoising step toward pictures that match the words. Now zoom all the way out. A real image is just a long list of numbers, one brightness per pixel. So a single photo is one point in a space with hundreds of thousands of dimensions. And since each of those numbers can take 256 values, the count of possible images is 256 raised to the number of pixels. A number with millions of digits. We can't picture that, so squash it down to this flat 2D map. One rule to hold on to: this is not a drawing, every single dot is one whole image, and the tight clusters are the vanishingly rare images that actually mean something.
So meaningful pictures are like a few small islands in an endless ocean of noise?
Exactly, and almost everywhere else is pure static. Now add noise to every image at once, and watch the whole map. Each point just random walks away on its own. But together, those separate islands blur and spread until they merge into one featureless sea of noise. Just how those islands really sit, truly separate, or joined by thin bridges, we don't fully know. It's a well-supported hunch, not a proven fact. Either way, the physics is the same as ink. Each molecule drifts at random, yet the whole drop spreads to fill the water, its density obeying the diffusion equation.
So diffusion isn't just a metaphor, it's the same math as ink in water?
Exactly. The islands of real images literally diffuse into noise. Run that in reverse, and the single sea of noise slowly separates back out into those distinct islands. That's what training really buys you. From anywhere in the space, the model learned which way leads home toward the islands of meaningful images. And because high noise had merged them all, you can always reach any island, drop a random, follow the learned direction, and it settles onto one as a believable picture.
And the prompt just decides which island you land on.
One process, any image, guided by your words. Swap our little 2D map for the real, million-dimensional space of full images, and you have today's image AIs. Stable Diffusion, DALL-E, Midjourney, all of them denoisers, walking noise home toward your words. Video tools like Sora do the very same thing across many frames at once. So the next time an AI conjures an image from a sentence, picture a field of static. And a patient hand removing exactly the right noise, a little at a time. The picture was always in the noise, the model just learned what to subtract.